for those notes from yesterday, 5.2. It says triangle ABC was transformed to produce triangle PQR by dilation with a scale factor of 3. Select the following statements that are true. What do we know about the pre-image and the image whenever we do a dilation? What do we know about them? Are they the same? Are they congruent? Are they different? When we do a dilation, what do we know? They're similar, very good. Which means the size of the pre-image, triangle ABC, is different than the size of the image because you did a dilation. You made it bigger, you made it smaller. Knowing that, the fact that we have similar triangles, as we did a dilation, is there one answer that we can mark off? We know the sizes change between the two triangles. What answer can we scratch off? We know the triangles are two completely different sizes. Sarah? You said B? Think just, right now we're not talking about what they're parallel or not. We're talking about their size. B. Good, we can scratch out B. PQ is not going to be the same size as side AB. PQ is bigger than AB because we multiplied AB by scale factor of 3. We can scratch that one out. Okay? But what do we do know about the size? What did we do to triangle ABC to get triangle PQR? What did we do to that triangle? When you do a dilation, what do you do with the figure and the scale factor? We made it bigger by doing what? What operation? We multiplied it by 3. Well, which one of these is stating that you took part of triangle ABC and multiplied it by 3? This one's talking about multiplying by 3. This one's talking about multiplying by 3. But which one's multiplying triangle ABC by 3? It says it took side AB and they multiplied it by 3 to get PQ. That's true. We multiplied a part of triangle ABC and it gave us that corresponding part of triangle PQR. Is C true? Did we multiply triangle PQR? We didn't multiply triangle PQR. That can't be an answer. Think about the angles though. What do we know about the angles of similar figures? Because we know we did a dilation. Therefore, the pre-image and image are similar. What do we know about their angles? Do the angles change at all? No, the angles stay the same. Whatever the measure of angle A was, that's the measure of angle P. The angles do not change with similar figures. Now knowing that, which answer can we circle? We can circle F. Which means we can cross out which one? A. The angles don't change. We don't multiply the angle by 3. We talked about this on Tuesday when we talked about dilations. When you do a dilation, does the slope of the corresponding sides change? You just do a dilation. Do the slopes change? No, the slopes don't change. So if the slopes don't change, what do we know about the corresponding sides? They're what? They're parallel. So what other one can we circle? E. We can circle E. Okay. Corresponding sides are parallel. The angles do not change. And you're multiplying the original triangle by the scale factor. Okay. Questions over that? That was a more trickier one. Really had to think about dilations and similar figures. Questions over that? Okay. We did that one yesterday. So now we're going to talk about mapping and how to map transformations with dilations. Similar to what we did last unit with mapping, but now we're doing dilations in there. An example course is use the transformation to the right to answer the following. So we're going to use this transformation here. Which of the following transformations would map figure MDNP onto figure M prime D prime N prime NP? We'll take a look at the pre-image and the image. What happened to it? They got bigger. Well, what transformation changes the size? Dilation. Well, at least we know it's a dilation. The size changed, so it's going to be dilation. Yes. Can you wait till I'm done? Because I don't want to have to see it. Thank you. We'll be done soon. I just don't want to have to pause, write classes, and things like that. Because it's a process. Purpose says write a rule to describe the transformation. When it says write the rule, it wants this. Okay. You had a similar question on your Unit 4 test. It said write the rule, and it was a translation. A lot of you did a good job at describing the rule. So you got points for describing the rule correctly. When it says write the rule, it's that like expression. Okay. So we know we did a dilation. So we know it's going to be the scale factor x, scale factor y. We just don't know what our scale factor is. To figure that out, look at your pre-image and find a flat side. What's a flat side in our pre-image? ND. Okay. And what's the length of ND? 3, right? Okay. Well, then find a flat side in the corresponding side of the image. Which side corresponds to ND in the image? N prime D prime. What's the length of N prime D prime? 6. Ask yourself, will I multiply 3 by to get 6? 2. What's your scale factor? 2. So you just put 2 in front of the x, 2 in front of the y. Now sometimes it's not that clear cut, it's not that obvious. Oh, I multiply 3 by 2 to get 6. That's my scale factor. Okay. So when that happens, when you kind of get a weird scale factor, you're going to do the image over the pre-image. Okay. Image over the pre-image. So we got that the side of our image was 6. We got that our pre-image was 3. What's 6 divided by 3? 2. So when you kind of get more weird numbers, you're like, I don't know what multiplies 3 to give me 6. Then you have to do that, and you'll get your scale factor. Sometimes your scale factor is a decimal, and it's hard to do. Okay. Questions over that? No? You just need to fill out that and fill this out. If we take a look at example 5, it says complete the statement to show that triangle RST maps onto triangle PYZ. Okay. Well, to map triangle RST onto triangle PYZ, rotate length degrees counterclockwise about the origin, followed by a dilation with a scale factor of blank. Okay. So again, with these, the answer is somewhere. You just have to guess and check. Okay. So you have to figure out, well, what rotation did we do? And then help you out. Again, if you can't recognize this, then try a 90-degree rotation. Then try one of the scale factors. If that doesn't work, try the next one. Go down your list. But there's something that can save you some time. Because we're trying to get RST, this upper triangle right here, to map onto PYZ. So we have to make this jump by rotation 1, 2 quadrants, because it has to be in the same quadrant to be able to do the dilation. Well, what rotation allows us to jump 1, 2 quadrants? 180. So I'm going to try that. Visually, I think I'm going to be doing 180 degrees. I'm going to try 180 first. Okay? So pick one of the points on RST. What is one of the points on it? Doesn't matter. R? I heard someone say R. We'll pick R. R is at 1, 1. And we're trying to get R to map up with which point in the other triangle? If R is written first, which one does R have to map up with? P. Okay? So, when we do a 180-degree rotation, actually, what's the rule for 180-degree rotation? Yeah, just flip the sign. Don't flip the point, just flip the signs. So +1 becomes -1, -1. I'm going to plot it. Did we end up in the same quadrant? Yeah, so far so good. Okay. So now we have to do our dilation. Is there a dilation or scale factor we can rule out right away? We have our options of 0.52 and 1.5. Why can we rule out 0.5 right away? Yeah, well, a 0.5 would make it become smaller. But to get RST to map up onto PYZ, we have to make RST bigger, which means our scale factor has to be bigger than 1. 0.5 is not bigger than 1, so we can scratch that out. So at least if you're stuck on what to do, you got a 50-50 shot of getting the right answer. Okay. But you just guess and check. Okay? Which one do we want to check first? Do you want to try 2 or 1.5? 2? Okay. So then let's do a dilation of 2. So I'm going to take my new r, my -1, -1, and multiply it by a scale factor of 2 to get what? Alyssa, what do we get when we multiply -1, -1 by 2? Yeah, we get -2, -2. I'm going to plot that. Did R map up with P? Yeah. But do we circle that, or should we check at least one more point? I would check it, just to be sure. Okay, sometimes I like to throw ones in there that throw you off. So I'm going to pick another point. I'm going to pick T. And T, what point is T supposed to map up with? C. Okay, T is supposed to map up with Z. They're both written last. So let's do the same thing. We're going to do 180 and then a scale factor of 2 and see if it works. And if it does, then that's going to be our answer. So we take a look at T. T is located at 3, 1. When we do a 180-degree rotation, Bree, what's 3, 1 going to turn into? When we do a 180-degree rotation. Yeah. So flip, change the sign of both. So that becomes -3, -1. Good. We're in the same quadrant. So then let's dilate it by a scale factor of 2. So if I have -3, -1, when we dilate that by a scale factor of 2, Sebastian, what's that point going to become? If we dilate this point by a scale factor of 2, what's it going to become? -6 what? 2. Okay, so let's plot -6, -2. Did T map up with Z? So then we know that's right. So I'm going to circle 180, and I'm going to circle 2. Questions over that? The next one we are going to map circles. Circles are a little different. Circles, remember when we dilate circles, we dilate them by their center, meaning their center doesn't move. Okay? So we don't do anything to the center, we do everything to the radius. So when we map circles, you have to be very, very careful. Okay? We want to fill in the blanks similar to what we did in example 5. It says we're going to map circle C onto circle C prime by translation blank units, and then a dilation with a scale factor of blank about the center of the circle. Okay. Well, what translation did we do? Because when we map circles, we want to map up their centers. That's what we want to do. So we want to figure out, how did I get C center to move over to get to C prime? Which direction and how many units did we move? To get C to map up with C prime. Naomi, where did we move to get C to map up with C prime? Good, and then we went where? Down 8. Oh, I'm not going to use purple. I'll use color code. Yeah, C went left 5 and down 8. And the center's mapped up. Well, I'm going to circle that. Left 5, down 8. We got the centers to map up. That's what you want when you do the translation to get dilations to map up, or circles to map up. Then we have to figure out the scale factor. Okay? To figure out the scale factor, you look at the different radii. We're going to look at the circle for the radius for C. Help code this a little bit better. What is the radius of circle C zone? We start in the center and count out. What's the radius of C? The radius of C is 2. Because again, when we do dilate circles, we always multiply the radii, or the radius, by the scale factor. That's what we got to look at to figure out what we dilated by. And then what's the radius of C prime? When we start on the center and count out, Nyla, what's the radius of C prime? 6. Start in the center, count out, you get 6. So then ask yourself, what did you multiply 2 by to get 6? What did you multiply your pre-image by to get your image? Sorry, what did you say? Yeah. So what did we multiply by? If our radius was 2, and then we got a radius of 6, what did we multiply 2 by to get 6? 3. There's your scale factor. And again, if you can't tell what you multiply 2 by to get 6, it's always the image over the pre-image. Okay? Always the image over the pre-image. So our image was 6, our pre-image was 2, and what is 6 over 2 simplify down to? 3. So that's how you know what your scale factor is. That's how you know what you dilated by. Questions over that? We got one more. Okay. Oh, fun fact! All circles are similar. Every single circle is similar to each other. Okay? Every single circle in the world is similar to every other circle in the world. They're all similar to each other. Okay? Because you can do any type of translation, like we did here, and any type of dilation with any type of scale factor to get a circle to map up with another circle. Okay? So all circles are similar. You might get some weird translations. It might be like, move 7.5 and down 14 3/4. Right? And then dilate by a scale factor of 7/5. Okay? You might get some weird numbers, but it is possible to translate and dilate any circle to map up with any other circle. So all circles are similar. Okay? Fun fact, important fact to know. All circles are similar. So, that being said, in the diagram below, circle F was translated and dilated to map up with circle F prime. Write the rule for each transformation below. And again, when it says write the rule, it wants that algebraic kind of expression. It doesn't want sentences. It wants more mathy looking things. Okay? So when we do our translation, we're trying to get F to map up with F prime. So which direction and how many units, Lewis, does F have to move to get to F prime? Do we move left or right first? Good, we went left 1. And then where do we go for it to finally map up? Yeah, down how many units? 6. Okay. So that's just describing what happened. We want to write a formal rule for what happened for translation. So with translations, that's where you say X what if we went left 1? -1. We went down 6, so we're going to write it as Y what? -6. That's the rule for the translation. You have to figure out how do I get my centers to map up. Okay. The dilation, we do the same thing we did on the last one. I'm going to figure out, well, what is my radius for F? And what is my radius for F prime? So when we count, Ryan, what is our radius for F? 3. Okay. And then when we count, what's my radius for F prime, Parker? 2. Just looking at this, do we know what we multiply 3 by to get 2? Is that an easy one to look at and know? For me, it's not. It's like, oh, wait a second. What do I multiply 3 by to get 2? So this is where you have to make that fraction. Sometimes it's not obvious. Okay? So remember, how would we make that fraction? It's what over the what? The image over the pre-image. Very good. It's image over the pre-image. The new over the old. New image over the old image. Pre or image over pre. However you want to think of it. So what was the length of our radius of our image? It was 2, right? And we got our pre-image radius was 3. Can 2 over 3 simplify? Oh, there's your scale factor. It's 2/3. Okay? What's 2/3 as a decimal? Yeah, it's 0.6 repeating, right? So if we round it, we can say it's like 0.67. I will accept either of those. So you can write the dilation rule. Remember, it's your scale factor x, scale factor y. I will accept that. Or you could have written it as 0.67x, 0.67y. I don't care, whichever one works for you. I'm fine with either. The OSC would be fine with either. So sometimes your scale factor is a little weird. It's not a nice, neat number, a whole number. Sometimes it's a fraction, so you just have to be careful of that. Questions? Again, fun fact, all circles are similar. So we could have taken circle F and mapped it onto circle C prime. Again, things maybe would have gotten a little weird with our scale factor, but it is possible. We could have taken C, circle C, and mapped it onto circle F. It's possible. All circles are similar to each other. Okay. Questions over that? Okay. That's the time to do it.